Hello, math people. Time for some more 2D geometry fun. Um, Yesterday we went kind of backwards. We went to parallelograms and we looked at if you know the area, how do you find the missing measure? So, guess what we're doing today? Same thing, but for triangles. So, we're going to go back to triangles um, and look at if you know the area of a triangle, how do you find one of the missing measures? So, first, let's do the same thing that we did yesterday. Let's start by just kind of re- redoing the basics of triangles. So, to find the area of a triangle, that is found by taking the product of the base and the height. Product means multiply, but then halving that. So, cutting that in half. So, one way to write the formula is base times height divided by 2. An alternative way to write that formula, if you prefer, is base times height. So it's still the product of the base and the height, but you could also multiply by 1/2 if you don't want to divide by 2. Choose which way you want to write the formula. It doesn't really matter, just that's the way. The other thing we talked about was what is the height in a triangle? Well, if you have a triangle like this green one, then the height is going to be probably this measure right here. I'll trace it in blue. Why? Because the height in any triangle goes from the base to the point that's furthest from the base, but it has to be a straight line. So it could not be this side because this is not a straight line. It has to be a straight from the base to the furthest point. So in this figure, let's say we were calling this the base. Well, if this is the base, this is the furthest point from the base, so the height would have to be a measure that goes straight down the middle because that goes from the base to the tallest point in a straight line. So the height, straight distance from base to furthest point from the base. Without further ado, let's go to some actual practice problems for missing measures in this triangle. Good old green triangle. We are told that the triangle has an area of 20 square inches. So if area equals base times height cut in half, and we know the area, well, let's see what we know in the problem. In this problem, I know the base is 8. It's the height that is in question. We don't know what that is yet, but we will. Similar to parallelograms, I encourage you to try to practice solving this algebraically using pre-algebra because that's what you're going to be doing the rest of your math careers anyways, so it's good practice. Fill in what you know. Step 1. I know the area is 20. And I know that the base is 8. I'm going to rearrange the order of this formula actually, and you'll see why in a second. For multiplication, commutative property says I can change the order. Order doesn't matter if I'm just multiplying. So instead of b times h times a half, I'm going to do half times b, which is 8 times a half. And the reason I did that is because now I can half times 8, I can just put that together and kind of simplify this side of the equation. So 20 is equal to, and 1/2 times 8, in case you forget how to multiply fractions, is just this. So 1/2 times 8, aka what is half of 8, is 4. And now how do I solve this problem? I have one step. The inverse of 4 times h is to divide by 4. Inverses cancel each other out, and whatever you do to one side, do to the other side, and that's going to result in a final, I'll go up here, a final step of 20 divided by 4 is 5, which is equal to, the only thing left over here, h, the height. The height of this triangle is 5 inches. So a quick recap. Step 1, write your formula. Step 2, fill in what you know. I knew the area and I knew the base. I just didn't know the height. From there, simplify what you can, use inverse operations, and you'll get a final answer. We're going to look at that a couple more times sometimes it's good just to have someone working it out with you. I encourage you, if you think you want to give it a try on your own, pause the video now and then unpause and check your work against mine. But okay, breaking this into steps. Step 1, it's a triangle. I'm going to write my triangle formula. Now, let's determine what we know. We know the area is 54. We also know the height, the straight distance from the base to the tippy top of the shape is 9 feet. What I don't know is the base. The base is a question mark. So I'm going to fill in what I know and then solve the problem using basic algebra. The area is 54. The base is unknown, but I know the height. The height is 9. And similar to the last problem, I rearranged. I've put the numbers together because when you're multiplying, you can put numbers right next to one another and change the order. It doesn't affect the problem. And 9 times 1/2, or half of 9, you can sit and do the work if you want. I'll just tell you that it is equal to 4.5. So then my last step here, hopefully you following along can answer what the last step is. I'm going to divide both sides by 4.5. So divide by 4.5, because that's the opposite of 4.5 times b. And whatever you do to one side, do to the other. That is supposed to be a 4. 4.5. Very sloppy. Tisk tisk. That leaves us with a final answer here. 54 divided by 4.5 is 12. And 12 feet, that's what this base is. It's 12 feet. If you're using a calculator for division or for other steps, it's fine. But the expectation is you're showing your work just like I've shown it here. This is complete work. If you want to show your division for some strange reason, feel free. It's no trouble if you want to practice your long division, but this is what we're looking for, something similar to this. I've got a couple more problems that I'm going to kind of work out. This problem, example 3, is actually the example that is in your notes for you. So I'm not going to totally work it out. I'm just going to get it set up. I encourage you to check the notes. This is a way for you to spend some time looking at the notes that have been created for you and see if you can finish the problem from there. So if you want to set it up on your own, base times height times 1/2. What do we know? We know the area, we know the height, we don't know the base. So plug in what you know. 56 equals 1/2 times the height times the unknown base. From there, try to solve it on your own. The answer is in the notes for today. If you've got questions on that and aren't quite sure how to follow along, just let one of us know. Send us a message, hop on a Google Meet if it's available to you. But I'm going to end today with 2 word problem versions of these same type of problems. This one, talking about a boat company designing a new sail. If you've ever seen a sailboat, typically they're really big triangles. Not always, but oftentimes they are. And this particular sail, the company knows, I'll draw it for you, that the sail itself is going to have an area, it's going to take up 60 square feet. That is the optimal size they've determined for their sail. It's the best possible size. And they know that they want to make the height. So the height is going to be, I'll try to make it super neat. It's going to be from the top to the bottom, this straight line. And go back to straight lines. And the height is going to be 12 feet. And obviously they want to say, what's the base? If we know we want it to take up 60 square feet and we know that we want it to be 12 feet tall, what does that make the base of this sail for us? How wide is it going to be? So area equals base times height times 1/2. and the area is 60. So the math on this one works out really nice. Nice, clean numbers. Divide by 6, divide by 6. So 60 divided by 6 is 10. So that tells this company that's creating sales, if you're going to have a 60-foot square, a 60 square foot sale that's going to be 12 feet tall, it can only be 10 feet wide. And there's your solution. Last one. So this plot of land that was purchased by a wildlife conservation group, it's triangular, and in total it takes up 9 square miles. So the space that's inside of here is made up of 9 square miles. They want to know, what's the distance from this point to this point? Well, looking at this triangle, that seems to be like the base of a triangle. And they know that from this point here down to the line that's created between those points is 3 miles. So how many miles is it from A to B? Well, simple, wildlife conservation group, we can all solve that for you. We can use inverse operations, some basic algebra, and a dash of awesomeness to come up with a final answer. The area is 9, the height is 3, and the base is unknown. 1/2 times 3 is 1.5. So your last step is going to be, what's 9 divided by 1.5? And your final, well, anyway, red, divided by 1.5, inverse operation divided by 1.5, and from point A to B is 6 miles. All right, if you have questions, let us know. Feel free to go back through this if I talked a little too quickly or moved a little too quickly. Hopefully you were pausing as needed. Use the notes from today and then complete the practice problems and show thy work. All right, later.